Okay, all again, a very good morning to one and all. I hope you all are safe and sound and taking care of yourself in this unprecedented pandemic. I, Yesha Bharucha from Navsari Agricultural University, wish you all a warm welcome in the Student Innovation Fest, a state-level competition organized by Vigyan Gurjari in collaboration with Gujarat Technical University. The competition has segregated itself in four categories of ideas like innovative software, innovative hardware, innovative combination of both software and hardware, and innovative idea from various fields. Vigyan Gurjari is one of the state-level organization under umbrella of Vigyan Bharti. Vigyan Bharti initiated as Swadeshi Science Movement in Indian Institute of Science, Bangalore, by a few eminent scientists under the guidance of Professor K.I. Vasu in 1991. WIPA has 22 states across the country. Main of WIPA is to champion the cause of Bharatiya heritage with a harmonious synthesis of physical and spiritual sciences, which nourish each other and flourish together. And today, on this platform, we shall have another insightful lecture from Mr. Ankit Patel on the topic latest communication technology and its implementation in industries like IoT, LORA, WAN. Before proceeding further, I would like to introduce our speaker of today. Ankit Patel sir has 20 years of diverse experience building embedded software and system for IoT, multimedia networking, semiconductor and industrial automatic products. At Cresco IT Systems, as founder and director, Ankit sir is responsible for steering business towards new technologies, formulating robust technology-centric business strategies, and leveraging technical innovations to address complex challenges. He has held a variety of senior leadership roles in both technology and management since 2001 and has several global markets including US, Europe, Asia Pacific, and India. He has worked with large corporations, SMEs, and startups and has been endorsed for bringing to the table discrete solutions. His passion lies in envisaging cross-domain technology applications that open up diverse avenues for business and is adept at implementing those. He has a bachelor's degree from LD College of Engineering, Ahmedabad. So now I request Sir to proceed with the webinar. Thank you.
Thank you, Isha. Thank you for a very welcome and giving a brief introduction about myself. So let's start about today's session, which is about communication and how it is being used in day-to-day technologies on commercial side as well as residential side. Before we move in there, let me first share my presentation, which I have prepared. So I believe I'm audible to all of you and should be able to see my presentation as well. Let me know if that's not the case.
Yes, sir, you shall proceed.
Sure, thank you. So today what we'll be discussing about, discussing about the communication, like what is involved in communication, various ways of communication, and then we'll dive into the IoT and LoRaWAN technology, which is comparatively new one and is being adopted very speedily in the industry. So first of all, what is communication? So communication is nothing more than what we are doing currently, like transferring information from one place, person or group to another, right? We are doing this session, that's communication, nothing more, right? The important part of communication are the information which is originated at one place or one person or one device, the media through which it travels, the format or the message or the protocol which passing the information from one place to another or one person to another, and the recipient who is receiving the message and using it for further knowledge or processing. So main four parts are sender, receiver, message, and media. Now, if we talk about media, there are two types of media. One is like wired communication media, and second is wireless. Communication types could again be two types. One is one-way communication, where let's say I'm speaking, I'm not getting any feedback. It's a one-way communication, where I don't know whether you got the message or there was a voice packet over the communication, and I don't have any feedback. It's just one communication that I'm speaking and you guys are listening. Two-way communication is like at the end of this session, we'll go for question answer. So that could be an example of two-way communication where somebody is asking question and then it is followed from some another. Again, if we talk about communication, there are three types of communications. One is broadcast, which is like there is a sender who is sending the message to everyone. So whosoever can listen to this message or receive the message will get it. Multicast is like you can say your WhatsApp group where you might have multiple groups and you are sending message to one group. So it's a multicast. So whosoever is there in that group will receive the message, which could be one person. Not everybody will get it, unlike broadcast. And unicast is like one-to-one communication. The most important part of communication is how do you format the message, the protocol, or the language. For example, in this session, we are using Gujarati or Hindi or English. What if somebody speaks in say, Telugu? I don't think people would understand that. So it's very important to have a common platform where systems or persons can communicate on platform. Now, if we talk about wired communication, it goes way back to telephone wires or coaxial cables through which our even television channels used to come to our home. Then later on came Cat5, Cat6 cables on which our internet and other communication media is being used. Currently, a few years back, fiber also got introduced in normal day-to-day use, where now all the homes are connected using fibers. There are certain pros and cons of each of these. For example, if we are talking about Cat6 or Cat5 cable, Ethernet cable, it can only traverse up to a few meters. Then you use some repeaters to strengthen the data signals. Fiber, for example, can go multi-kilometers. So depending on your need, you have to choose your right communication media. Let's move forward. The another part is wireless media. So it started all the way back to IR, which is infrared LEDs. If you remember the remote controls, even today, few of them are using IR LED to give signals to the systems they are controlling. Later came Wi-Fi, Bluetooth, RF. All these are like radio frequency waves are being transmitted and received. These are like bidirectional communication normally. Then came Zigbee. It's again a RF communication, but it uses a different network topology, which we'll be looking at in coming slides. NFC, everybody is aware of NFC, which is common nowadays in your smartphones, where you can transfer files between two smartphones if they are in vicinity. Right? Cellular is there for many years now, decades, I would say, starting from GSM mode, where we were using it for making calls to each other, sending short messages, SMS services. And nowadays we have reached up to 5G and new technologies yet to come. Another portion is like LoRa, LoRaWAN or Sigfox or NEUL. Almost all of these technologies are similar and they are like bridging the gap between speed and the distance and the cost. Satellite is multi-kilometer communication media, but it is a costly one and low-speed communication. Normally, it's not being used unless there is a special case, right? So if we talk about all these wireless technologies, you have to, when you go for a communication media selection, what you have to first do is find out which one is more applicable to a particular use case. It's not like one technology is the best and another. It's like depend on your application. For example, it's for between two mobile phones. They can use NFC. if both the phones are nearby, if both are separated by, let's say, kilometers or meters of distance, then you have to use some other technology. It could be your 4G, it could be your Wi-Fi. Through network, you can transfer the data to each other. Where you don't need speed, but you need the battery life, then you have to go for communication technologies like LoRa, for example, which covers the long distance, low data rate, and higher battery life, lower power consumption. Where you need medium-sized distance, but you need redundancy in the network, there you can use technologies like Zigbee, which creates the mesh network. We'll be looking at the how mesh network works in coming slides. But there, if end-to-end device is not in range of each other, they create intermediate nodes and transmit their information from one device to another one. So let's look at those, how it is actually being done. So connection, first let us look at the connection topologies. So there are various connection topology. Way back we started with point-to-point connection topology, where one device is only connected with another one device only, not more than that. So both of these can communicate with each other, but they cannot communicate with the outer world directly. Then came the star topology. Star topology, you can take the example of our wireless router, which we have installed at home. So it provides the wireless connection to all the devices, or maybe wired connection to computers and other devices, TVs, smart TVs like that. So this router at the center of your network and connects all the devices which are connected with that. So two devices of this topology cannot talk with each other directly. They have to go through the router only. So plus point is you don't need many wires to connect all the devices with each other. Still, you can talk with each other, but the router is your center part. If your router goes bad, your whole system communication breaks down. Then in past, bus topology was used. Nowadays, you might not have seen this. It is like a common wire goes by and then there is a loop created. In industry, it is still being used. For example, Modbus you might have heard about, or RS485 you might have heard about. There this system is being used in industry, but residential or other commercial establishments, you won't be able to say this. So this is mainly like there is a common wire and each device is connected to that wire. Of course, there are limitations such that not multiple devices can transmit at the same time and you have to manage if conflict happens over there, over the media, right? So low speed, but again, the wiring cost comes down. So there is, as I mentioned earlier, there is a trade-off between what media or what topology you use for your need. Let's move forward. Another one from past is a ring topology, whereas shown in the diagram, each device is connected with two other devices and they transmit the messages. Now here, if you can see, one device might not be directly connected to another one, but the message hopping happens over here. So one device sends the message to the very nextly connected device. The next connected device will check if the message is for himself or it has to forward it. If it's not for that device, it will be forwarded and so on. So ultimately the message reaches to the required device and the purpose is served. There is a tree topology also. How it works is there is a root device at the very top of this tree, and then there are branches, and there could be sub branches as well, as shown in this device. So you have a root or your main device, which is your center here, and then it gives is connected using media to other branches and so on. So if it has to traverse from one sub branch or one end node to another end node, it knows okay how the topology is. I mean, which device is connected to which branch and where it has to traverse. All that information is there in the network, and accordingly the message is being routed. We talked about the Zigbee protocol, which is an example of a mesh network. The benefit of that network as shown in this diagram is, let's say you have a RAID device, which kind of you can assume it's a satellite device. You have two blue routers shown on the screen. We can say that those both of them are connected with that satellite. So they can, satellite is your root device in here, the main device. Then there are two blue routers, which are in turn connected with yellow routers, which are nearby, connected with blue dotted line. And those yellow routers are also repeaters, which connects to the far end router, which are connected with pink or red line. So the benefit of this system is, if one of your router goes down, another one takes over and transmits the message to the end device. Secondly, even if your end device is not in direct range of your blue router, then also it can communicate using the intermediate nodes, which ultimately gives the message to end device, I mean, wherever it is going. Yeah, these systems normally have self-healing thing. Say you started the network, it had 10 devices, all of them got connected. Now one of the intermediate device got down for whatever reason. It could be battery drained out, or it went out of service or something. Node, which is intermediate one, will take over its place and keeps on forwarding messages to and from. We could also see the hybrid topology. What is hybrid is whatever topologies we have seen till now, combination of that. For example, on screen it's shown that, okay, you have a star topology connected with ring topology. Okay, so different mix and match between the topology. Again, there is no thumb rule of which technology you can use where. You have to go by your experience. You have to study the pros and cons of each and every connection topology. And based on your need, you have to apply which one works best for your needs. There is another thing which you have to decide when you are talking about connection media or topology or thing you are using. For example, on screen, I have shown a very selective things like Wi-Fi, Bluetooth, cellular, or LoRa and similar technologies. So let's say if you have to transmit your voice, or we are doing this video conference, right? So you cannot use a low speed device. You need to use a communication technology which gives you higher speed. It could be at a higher power consumption, but you need speed. Otherwise, your video or audio will be choppy and you won't be able to hear me clearly or anybody else, right? So you have to choose speed over here. Normally, when you go for longer distances, longer range, your speed comes down. That's why you might have seen that, okay, if you're on 3G or 2G, your video doesn't come that smoothly. Versus if you go on 4G or Wi-Fi, your video is smooth. Cellular technology, on the other hand, it provides you your connectivity while you are moving around, you're roaming, because it has a higher distance, it covers longer ranges, and comparatively, it also provides the better speed. Now, if we talk about today world is going towards IoT. IoT is like device which has sensors in it or some information and transmit that information on itself. Okay, and over there you don't have much information, all data bytes or some small packets which you need to transfer. So that speed is not that much required, or not that much required, but you need to have a lower cost and higher distance. And sometimes it should come along with lower power consumption. So it could work in battery operated device very well. Okay, so this segment is mainly covered with LoRa, Sigfox, or similar technologies, which are like low bandwidth, low speed, but it gives you a higher range or almost similar range as existing cellular technologies. But it is again low cost and very low power consumption. So you can use battery operated device using this. So let's just recap about this. What we discussed. went through till now is what is communication, the media used for communication, topology, speed versus range comparison of different technology. Now let's look at just briefly look at what is IoT. So IoT is you can say it's a concept rather than a technology. It's a concept that okay, you can do this. Let's say you can do home automation. Everybody is using this home automation, right? Okay, let's say you are using your mobile phone to turn on or off lighting, or turn on or turn off your AC or other devices, right? So that is kind of home automation where you are giving command through your mobile phone. Ultimately, it goes through some network. Let's say it goes to your main router. Router gives command to something else, which is your main controlling unit, and it ultimately gives command to your end device, which could be your light, your fan, or anything else in your home. Also, the same thing is used for smart city. Smart city, you might be talking about, say, smart lights, right? Street lighting, which is off at day, turns on at the night. During the night, if later hours the alternate light is on to save the power, it could dim itself to save the power again. It could be used for your waste management system, say where the bin is full or it's empty, or all the information where the trucks are moving, every information be collected and shared with the operators so they can use the resources in a better way. Healthcare also it's being used. For example, for elderly people, let's say they are living alone or some time of the day they are alone. So there are gadgets which they can wear. So if for some reason they fell down, there is a gyroscope or sensors inside that object which gives signal to concerned person. It could be your doctor, it could be your neighbor, it could be your own people who are living with you but not with you full time. So they get a signal, okay, there is some accident happened over here, so immediate medical care can be provided. Similar concept is used for pet care, where they put sensor on your pet, so if they go out of your home boundary or a geolocated area, then you get an alert. Even they have GPS inbuilt, so you know where your pet is moving, so you don't lose your pet and you can go and get him back. Industry also, it's being widely used, starting from water meter, electricity meter, everywhere it is used, or during the factory automation also it is used, like you want to control the temperature of some area, you want to control humidity of that, you want to control pressure of some area like boiler or some pipes, then you can do that. All they do is there are sensors installed at different locations of critical point, and also there are some control mechanisms installed. The control could be, it might be operating your valve. If it is a flow controller, you might want to open or close valve or adjust it. It could be your heating or cooling systems. It could be your door systems, which allows access to somebody to some area and doesn't allow access to everybody. So this kind of system is used in industry everywhere for automation as well as to maintain certain critical criteria. Automobile also it's being used. For example, you might have heard about highway accidents where cars are stacked up, right? Let's say there is some accident between two cars and other cars are coming in speed from behind. They will clash into each other if proper care is not taken by the driver. Let us assume that all the cars are fitted with a IoT device which transmits the information to nearby traffic. Okay, there is a collision over here, so be extremely careful. And some buzzer or something comes up if you are driving to that direction. Those kind of accidents can be avoided. These are being used nowadays. Still, it's not very common, but it will come in coming days that, okay, you will get this kind of sensors in your car just for betterment of people. Vending machines, for example, let's say some vending machines are running out of material, whatever it is, your drink or your snacks or whatever it is. If it is running out, it can send information to whosoever the owner is for that vending machine, and he can refill the supplies in that machine. So he doesn't have to move around and find, okay, which supply is low for installed machines, and he just gets the information sitting in his office that, okay, this is running low, and he can go and refill it. Same applies for your supermarkets where shelves are running empty. It doesn't have to move staff all the time to find out where it is empty. There could be sensors placed which gives the information, okay, this supply, particular item supply is running low, and they can refill it in time with very effort. The story goes on like smart parking, where when you enter a parking, which is a multi-story, and you don't know where the empty slot is, there are signboards available with sensors which says where the parking is available and how many slots are available. You can choose from there, go and park your car or your vehicle and can easily move out. So these are different uses of Internet of Things. Again, the concept is your devices, which are small sensors, that passes information using different media. There is no specific media. It's not tied to a single media. You can choose any media based on your application. And ultimately, the purpose is to get the information to make the optimized use of resources and get the things done in an easier way. Now, before we move to technology, does anybody have any question or any doubt till now? Okay, I guess the answer is no. So let me move toward LoRa or LoRaWAN, and then we will look at how it can be used in this IoT devices we talked about. So LoRa and LoRaWAN, both of them are using the same underlying architecture, which is LoRa, which uses a spread spectrum thing frequency. So let's first look at what are the benefits of LoRa or LoRaWAN. So LoRa provides, it's a short form of long range actually. It provides really long distance, it covers really long distances, and practically people are using it for up to 15 kilometer aerial. Now, like any other RF technology or wireless technology, the range will depend on your environmental factors. For example, buildings or trees are coming in between, the range will decrease. But again, practically, people have achieved multi-kilometer distance in cities as well as in open urban area, rural areas as well. It consumes low power. Frankly speaking, it goes to very low power, which is in milliwatt. And you can really use battery operated sensors for years to come. So it's not like every few weeks or few months you have to change your battery. You can use the same battery for years and still that sensor will work with its full capacity. The flip side is the data rate is low or the bandwidth is low. So you cannot transmit whole bunch of data, but you can only transmit small data like a sensor data or a small command or something like that, like turn on the light or turn off the light. But you cannot transmit the voice over the LoRa technology that requires higher bandwidth and real-time data. Most of the or almost all the countries are using license-free band. LoRa is not bound to a single frequency. It uses different frequencies like 433 megahertz, 868 megahertz, 916 megahertz. Different countries have adopted different version of those frequency, and they are called ISM bands, which are free to use. Of course, each country has put on limit on which channels you can use. So it's not like, say, LoRa is providing, for example, 8 channels. It's not like all countries have opened up all the 8 channels. India, for example, has only opened 3 channels. So you can freely use those 3 band only. You cannot use other bands of LoRa. There are restrictions from country to country on your power at which you can transmit, your cycle at which you can transmit. Here, duty cycle, like, during the day, let's say there are 24 hours. How many minutes out of that time you transmit, that is restricted from respective countries. UK might have a different restriction than India, might have a different restriction than USA. So you have to study your regional parameter before you actually deploy your devices on this technology. So it is license free, you can use it, but there are restrictions along with it, which you have to follow. Another benefit of LoRa is it has deep indoor penetration. So what happens is, let's say we are using Wi-Fi nowadays, uh, but you don't get coverage in all your rooms. If you're multi-room or your apartment or your house is big, or you don't get it coverage on all floors, right? You have to use multiple routers to get it. On the other side, LoRa, we can get a coverage even for multiple floors. Let's say you have 7-floor building, you can easily get coverage on all the floors using same single gateway of LoRa. So you don't have to use multiple routers or gateways to get coverage. So it has a deeper penetration, indoor penetration through RCC or over wall also. You can get geolocation of your device without using GPS. So that is a technology called triangulation technology, which uses the very fine timestamps and find out the location. You might be aware that GPS, right, how it works, that, okay, there are multiple satellites placed in the atmosphere to give this signal to GPS receivers. At any point of time, if there are four such satellites which are transmitting signal which is being received by your GPS, then it will be able to accurately find out your location based on the timestamps given by the GPS satellites. Similar concept is used here, where devices can be found out without using GPS. Of course, there is accuracy with which it works, but you can at least get a decent accuracy of your location of your device. Roaming, it also works in a better way. Let's say you have installed a LoRa or LoRaWAN based device in your car or your bike, and you are moving with that between two different gateways. It works in a seamless manner, like we are getting it for our GSM coverage today. You are making a phone call. Most of the time, the call will not be dropped if you are moving from one tower to another. The traffic continues. It just changes tower from one to another. Same way in LoRa or LoRaWAN, it works like that. If you are moving with the sensor or the end node, you are changing your gateway, but your traffic will continue. Another better part is there is a ADR or automatic data rate selector, which is inbuilt in LoRaWAN protocol. The benefit of that is if a device which is nearby to your gateway or router, it can use higher speed and more bandwidth. The device, if it moves away, or device which is located away from your router or gateway, it negotiates down to a slower speed, slower bandwidth thing, but it can still communicate. It is not like I will just talk at one speed and everybody has to listen at that. Depending on the power of transmission, depending on the distance, depending on the environment, it adapts to the required speed and bandwidth and power. Now let's look at the architecture of LoRaWAN. So there are main four components of an architecture. The first one is end node or devices or the sensors with which the LoRaWAN is attached, which is ultimately sending data to your server. This could be your temperature sensor, your humidity sensor, your light being controlled by that thing. It could be any such device which at the end of this topology or at the bottom of this topology. Then there are intermediate devices which are like gateways, very similar to our routers, home router, which we are using for our net connection. These are most of the time like a packet forwarder, which takes the information from end node and give it to the server, network server, or takes the command from the network server and passes to the end node, which is being in picture at moment. So those gateway devices do talk on LoRa or LoRaWAN protocol on one side. Another side, that could be another technology, which could be wired or wireless technology like Ethernet, your 4G, 5G, LTE. any technology could be there. So it's like you can say it's media converter, which converts your LoRaWAN protocol media to your another media, which could be your 2G, 3G, Ethernet, 4G, LTE. Now, all those gateways are connected with network server. The role of a network server is it manages the gateway, it manages the end devices, it allows connection, disconnection of those devices, and allows it to transmit messages. It also controls which gateway is a public gateway, which gateway is a private gateway. What I meant by public and private is you might be creating your own network, which is only used by your own device, and its network. Other devices cannot connect with this network. It's like you have a tower, you have a Reliance tower. Vodafone will only allow its own SIM cards to connect with it, unless it has some pact with other vendors. Same way, Jio will not allow Vodafone SIM card to be connected unless there is a treaty between them, right? So Vodafone it's a private network which rents to normal people to use it. Similar way, you can have your gateway set up as a public gateway and you can provide service to others, or your gateway could be a private network where only your devices can connect through it. So all this configuration control is done by your network server. Once a device message or is okay and your device is allowed to connect, it passes all the messages from the end nodes to the application server, or control messages coming from application server to gateway, ultimately to the end node, right? Application server is your specific thing, which, for example, if we are talking about different sensors, right, temperature sensors, so they can be sending a message from end node to the gateway to network server, and network server knows which application that message should go to. So you could have multiple applications running, multiple application servers would be there, single network server. Right? So your different sensors do send messages to your different gateways, which gets routed to network server, single network server, and this network server will again route the message to the appropriate application. Same way, application server can give command to the network server, and ultimately it reaches to the end node in picture. Okay, so this way bidirectional communication happens. Now, for security point of view, all exchanges happens with AES encryption, and there are two layers of AES encryption over here. One which is done at network server level, another one which is done at application layer or your application server. Now let's move on. How the activation happens. So as I said, you could be connected to your gateway and the connection disconnection is controlled by your network server. There are two mechanisms using which end node would be connected, or your end device or end sensor can be connected with the network. The first mode is called OTAA, which is over the air activation. Second mode, which is ABP, which is activation by personalization. Now, over the air activation. So, over the air activation is like there are some predefined keys which are configured in your end node and which are configured on your network server. If the key matches, they exchange some messages during the join process or the activation process. So, let's say end node sends a message encrypted using the key configured in the end node. It sends the message to the network server. Network server will try to decode the message using the encryption key available in the network server. And if it is able to decode that message properly, then it will find out, okay, the device is authenticated to move forward and join the network. So what it will do is it will send back an acknowledgement for that message saying, yes, you can join, and that is also encrypted. The end device, once it receives the message, it finds out it is authorized to join, and then the new traffic will go on, and encryption for that is negotiated during this join process. Meaning your key changes every time you join the network. It is not a same key which you use for all the communication throughout your life cycle. Every time your device joins a network, it negotiates a new key. This way it is more secure. Somebody hacks your key out, but it cannot use for lifetime. The next time the device joins the network, there will be a new key generated and used. While on the activation by personalization, it uses the encryption, but the keys are fixed. So once you install the device, you commission the device in the field, the keys are fixed throughout the lifetime or until you change it. So activation by personalization and over-the-air activation both uses the key encryption, but benefit of OTA mode is the key gets negotiated every time you join the network. So it is more secure, more advisable to use in industry. Now, based on once you join the network, you are transmitting the messages. Now, LoRaWAN protocol allows three types of operation, which are three different classes. The first one is class A, class B, and class C. There are three different classes. Each one restricts the when gateway or network server or your application server can send message to your end device. This segregation is based on your application. It depends on your application, how you want to use your device. For example, if you want to use your device for a battery operated device, then class A mode of operation is recommended, which saves your battery. It lowers down your power consumption and your device is in sleep mode most of the time. If you are operating using mains power, then you can go for class B or class C type of operation. We will look at all these three operations, how they are different from each other in coming slides. But you have to choose according to your application or your end device, how it is operated. From gateway point of view, network server is just restricts how the messages are being transmitted. Now, as we discussed earlier, there are like which channels you can use for LoRaWAN communication. What is the duty cycle of your device? Okay, you can transmit for 1% of your time, or you can transmit for 5% of your daytime. That is restricted by country laws, and each country have their own law. Now let's look at the class A mode of operation. So the very first message you are seeing over here, uplink message. What is uplink message? So uplink message is any message which is being transmitted by your end node or your sensor to the server. And downlink message is on the reverse direction, which is from application server to network server, all the way from gateway to end node, which is called downlink message. So it goes by your topology, right? So let's assume the application server is at the very top and your end node is at the very bottom of this transmission topology. Then your uplink message is from bottom to top, which is end device to the network server and application server. And downlink is from application server all the way down to the end node. So in class A mode of operation, end device, which is your sensor or any other device, can transmit a message at any time. It doesn't have to wait for any signal from gateway or server that it can transmit. Whenever it has data, it can transmit that data. The restriction is on the application server or gateway that it cannot transmit data to end node all the time. Why this? It is just because to save the power. Any wireless communication, it consumes maximum power when it is transmitting or receiving messages, or it is listening for message. I mean, waiting for message to come. So when you are using battery operated device, you don't want to power down your transceiver so that the battery life is elongated. So in this case, the protocol itself very clearly says that for class A mode of operation, your end device will be in idle mode or in power down mode for those two green windows, other than those two green windows which are shown here on the screen. So most of the time during day, those sensors are powered down. Let us say you have a temperature sensor where this LoRaWAN protocol is used. So what that's and it is battery operated in class A mode. What it will do, you have to set up a frequency. Let's say every hour you want to get a reading of that sensor. So the sensor will be in power off or hibernation mode most of the time. Every hour it will come up, it will measure the temperature, it will send the temperature data to your server. So if you see this way, let's say it takes 1 minute to measure the temperature and send it to the server. So calculation would be for a rest 59 minutes, the sensor would be powered down. Okay. So it doesn't have to be on all the time and you can save battery. As we move on to class B and class C, the receiving window gets open. So your battery consumption comes up. That is why it is advisable for battery operated devices to use class A mode of operation. The only flip side is your server cannot always send the message to class A device. It has to wait for that window to come up and then only it can transmit message. We give some more of time where server can send beacon and then there is a duration in which you can message. So class B mode of operation is server doesn't have to always wait for device to send a message and only send. It can send in other windows as well. And last mode of operation is class C, where send message time. Server does not have to wait for device to wake up and go in listening mode. It can send message anytime and the end device is in listening mode. So it will receive the message sent by the server. So applications of this: smart metering, smart agriculture, smart cities. We discussed about those. Healthcare, we discussed. So any place where you have scattered network, agriculture, for example, your cell phone towers over there, the network coverage might not be there. So you can go set phone coverage and get the data. For pets, you can give variable to your kids, and if they are roaming around, you know where they are in your flat, apartment, or societies where they are. You can find out industry, different sensors are being used. Security purpose also, you can have door sensors and other proximity sensors used, and they send data whether there is a movement, whether it's open or not. And for all this, you can use LoRa, where you don't need much data, but you need reliability and distance with a low cost. So what we have seen so far for LoRaWAN is salient features, the architecture of LoRa, like network server, four main parts: end device, gateway, and network server, and application server, the classes of operation and applications used in IoT devices. So I can say LoRaWAN can be used for many IoT applications. So that is what I had for today. Now let's open it for questions you might have.
Sure, sir. Sir, very well explained and precise and detailed manner. And we all had a great time hearing you, starting with the base, that is definition of communication and its concept of IoT and LoRaWAN. So now
So now
the
the
session
session
is open
is open
for
for
questions.
questions.
I request all the
I request
participants
all
to
the
write them the
participants to write them the
queries in chat
queries
box.
in chat box.
84 डेज बाद बोल रहे हैं बार बार, 83 डेज बाद बोल रहे हैं बार बार। कल गए थे हम हॉस्पिटल, तो बुधवार शनिवार को हो गया सीतापुर में,
Sorry.
1 लग गई। हाँ जी जी।
Sir, can we wait for a couple of minutes?
What is the question actually?
Sir, I was
I
telling,
think-
can we wait for a couple of minutes for participants to note down their queries?
Ankit sir, can you
Sure.
give any idea about the what is the future of this technology in India?
Sure, sure. So, as everybody knows, like government is heavily going after the smart cities and smart agriculture, right? So, for example, you can assume like in smart cities, you have ambulance moving, okay? And as of now, there are traffic signals which are not aligned with it. Okay, so the same technology, IoT technology using any media, including LoRaWAN, can be used so that it sends the signal to respective traffic signals because it knows from which place it is going to which place. So wherever the traffic it needs to be stopped, it can be stopped. Same way for garbage disposal, it knows where the resources are, where the chalk up is, where is the bottleneck. It can do the same thing. Agriculture, whether there is a power or not, whether there is a water or not, based on that, it can decide when to turn on the pumps or turn it off. You can also restrict the supply of the water and stop the wastage of it using this technology, right? The smart lighting, the emergency, there is no way you can communicate to your country members, right? So you can use that system also where alarms are being installed at light poles and then the communication happens in case of emergencies. So this could be different ways it can be used in coming days. The car system we talked about, early warning system. Okay, there is an accident on this road. Maybe you can choose to have alternate road, or you can at least avoid more accidents on the same place and surprises to fellow drivers.
Thank you, sir. So there is another question from audience. How can I speak up?
Yeah, please.
How much signal power is used in LoRaWAN?
Yes. So the answer actually depends on the mode of operation you are doing. So class of operation. So if let's say you are talking about class A, it can go all the down to 20 milliwatt. If you are continuously listening, it will be in hundreds of milliwatt. If you are like transmitting with higher power, it will consume more power, right? Let's say you are transmitting at 20 dB versus you are transmitting at 5 dB of power. Then your power consumption will depend on all those modes. But you can go all the way down to few milliwatts. There is no limit that okay, this is upper power because as you know, I mean, if you have to transmit for multiple kilometers, right, you have to use more power, bigger antennas. If you have to transmit just nearby with very less data, it is less. Okay, it also depends on the amount of data you transmit, the speed of transmission, because if your device is nearby, it can transmit at higher speed as we saw through the presentation. Then your airtime is low, you can save the power versus if you're transmitting to longer distances. I hope that answers your question.
Yes, sir. I hope JV Patel sir is clear with the answer.
Yep.
Yeah,
Yes, got
we got a positive response. Sir, there is one question from my side. Since the technology seems to be automatic
आज जाके बात
and
करनी है और क्या
feasible,
जाके
I request Ravi sir to please mute themselves.
आज जाके बात कर लेंगे उनके घर जाके।
Okay, so I was telling the technology seems to be more automatic and feasible. So can we link, can the technology help to differently able people, and in what manner?
I'm sorry, can you please come again?
Yeah, so I was telling as the technology that you explained, like IoT and LoRaWAN seems to be more automatic and feasible. Can we link their applications and their positive view for differently able people?
Sure, sure. Yes, we can. For example, uh, even LoRaWAN is nowadays being used for people with, let's say, who need to use the hearing aid, for example, right? Because it's a sub megahertz, it uses the megahertz communication. It has a long battery life, so it is being used over there. For example, people who have visibility related issues, they can get a traffic kind of sense. Okay, they can listen, right? I mean, so traffic signal, whether traffic is on or not, there could be some sensors placed at the crossroads which can give the signal to that person or whoever is in vicinity and guide him. Okay, so this way, yes, of course it can be used. Or like a person who is in wheelchair needs assistance, or is stuck somewhere, he can send the signal, SOS signal, using this technology.
Yes, sir. Thank you. So, any more queries from audience?
Yes, ma'am. Sir, there are lot many protocols available like Threads, Zigbee, Z-Wave, LoRa, Sigfox. So, which can you please suggest some protocols which can be explored for B student for IoT?
See, as we discussed, right? I mean, it's like, it's not right or wrong, it's a gray area. There are so many protocols, as you rightly said, and each protocol has their own pros and cons. Okay. For example, if you talk about Sigfox versus LoRa, both are almost similar. Their applications are similar, but they are being promoted by different entities. Okay. So when you go for selecting your communication protocol, I would recommend you first look at your application, what you need. When you are making IoT device, I mean, do you need your throughput, or you just need to communicate reliably? Okay. What kind of application that is? Do you need to operate on battery? Right? Because if, for example, if your device is going to operate on battery and you choose mesh network, right? It doesn't go well hand in hand. Reason is, for mesh network, your intermediate devices has to be continuously powered on, versus end devices which can be powered off while they are not communicating, right? So if you're using a battery device with a mesh network, it will drain your battery and you will not get the benefit of battery operated device. You will have to continuously keep on changing battery. Protocol point of view, I could say LoRa or NB-IoT, you have to go by where the companies are going, right? For example, currently in LoRaWAN and NB-IoT, there are lots of investment being done. Why I'm saying go after investments or where companies are going, those protocol will go longer way. Okay. If there is no ecosystem, right, the protocol will not being used by others. It will die after some time. And as of now, all these are evolving technologies. There is no right or wrong for anyone. Let's say if you ask, okay, whether I should use NB-IoT or LoRa, should I use LoRa or Sigfox? There is no right answer. There is no wrong answer. You have to see where you are going to apply that product or thing you are developing, and which network is available over there. Are you going to set up your own network? Then it doesn't matter which technology you use as long as it serves your purpose. But if you are going to use a public network, right? And let's say you are doing something related with agriculture and there is no network, what will you do? You can't do anything. So you have to choose a technology where either you can control or it's readily available, and then go for it. And of course, those LoRa, Sigfox, and NB-IoT are upcoming technologies for IoT related devices, and they are getting cheaper day by day.
Okay, thank you, sir. And can you, sir, can you please explore which companies right now using LoRa? Can you tell me some sites where it's using right now?
Yeah, I would suggest there is normally there is Wikipedia, right? So similarly, you would find the things network. Okay, if you refer to that site, for example, it very nicely covers the concepts of LoRa and also devices where they are available from different manufacturers and how they are being used. Even they provide information on where public gateways are also available.
Can you please repeat that website's name?
Sure, it's the Things Network. Let me put it in chat so you can get it.
Okay, sir. Okay.
Okay, you
And
will
sir,
get nice
Your
information
question
over.
is related to implementation of the project you developed the Anita madam.
it's so if it's implemented, then we can bit explore which kind of things they have implemented. Like I have seen in project, even I have the doubt how we are connecting our sensor node with gateway using this LoRa. So is there any devices in between gateway and end devices? That is again one question, sir, because I haven't idea about this topic.
Yeah, sure. So there are no other devices. There are only four things as we discussed. The end device, which could be your sensor, for example. The gateway, which is similar to router. So it converts your LoRa protocol to your other communication media. For example, Ethernet. Okay, so they communicate directly, but yes, it is a bit complicated than that because here you need to authorize the device to connect using that gateway, which is done on the network server side. So I'm sure, I mean, this site will provide you that information, how your devices can be connected. So basically, if you want to establish a network yourself, what you will need this device sensor, which has the LoRa. You will need a gateway. You will need a server where you can install the network server software as well as the application software. Another option is the site which I mentioned, the Things Network. They also provide application as well as network server, which you can use. So you don't have to worry about installation of software and everything. You can test your device there also.
Okay, sir. Thank you so much, sir. Thank you.
One question asked by J.V. Patel, sir, in how can you use LoRaWAN technology in power sector if you give some idea?
Sure. In power sector, for example, there were some trials in recent past also to use RF technology, right? The problem with that was the RF range is normally shorter, so you have to use multiple repeaters. Even in smart meters, right? RF is there, so you have to keep on using the repeaters to get the data. Now, if you don't need that much data, let's say if we are talking about power sector, what you have is energy meter or some sensors installed at different devices, right? So door is open, switch is closed, or similar ones. So there, or let's say you have FPI, for example, which indicates your fault occurrence on high tension lines. So over there, if we can use this kind of sensors and it sends the data to your gateway, the benefit would be you get multiple kilometer range. Practically, what we have seen is in cities, the dense cities, you can get around 1 kilometer of aerial distance as a range for a normal gateway. I wouldn't say high-end gateway. There are high-end gateways also available, normal gateway. Agriculture, you can easily get multi-kilometer coverage. And if you don't need to transmit data too often, let's say you're transmitting data only when fault occurs or once in a day or few times in a day, then you can use this kind of network. So you don't have dependency on your network provider. You don't have to have monthly expenses, and other management issues will go away, right? So basically, to answer the question, yes, you can use it for meter reading, you can use it for your fault indication where the fault occurred, or you can even use for power availability also, say up to which point the power is available in your tree. Okay, the next question I read is, can the devices used in LoRaWAN technology tolerate outdoor weather conditions? Yes, it can. In fact, we have been using it for some time now, and gateways as well as end devices, they can tolerate the power. But answer also, there is a condition that your whole device needs to be built up that way. Because it's not just the LoRaWAN, right? It has some sensor or some other mechanism which collects the data and sends it to somewhere, or which controls something. So your whole system should be designed with a purpose that it is going to be used in outdoor weather conditions. Otherwise, it
And
can
sir,
be used 24/7.
and sir, currently up to which IP range the devices are available? Which IP class?
Are you talking about ready-made devices or custom-made devices?
Yes, both.
Yeah. So even I'm sure you will be able to find sensors particularly, because sensors are widely used and they are main fit for purpose thing for this one. You will find up to IP6 or IP66 or 67 for this kind of
Okay,
device.
66, 67 available. Okay, good.
Yeah, it is. But again, it goes by purpose, right? I mean, if you are going to use inside box enclosure, then you might not need that much. So it will be dependent, but sensors are available up to IP67.
And can this sensor be used in extremely humid conditions where suppose relative humidity is above 90%?
Yes, you can, because just let's see, because you are using it over here, right? And are you talking about just humidity sensor or any other sensor?
Need any sensor, but if the surrounding environment is very humid, just like underground power plant. In a hydropower
Right.
plant, we have underground station, and where in monsoon time, there is relative humidity up to 93, 95%.
Hmm. Right. It can be, but you would have to study that data sheet of that particular sensor,
Hmm.
right? Because if it is
Okay.
properly packed, right? Even now, nowadays our phones are also IP protected. You can use it in such devices. Of course, there are industrial grade products available, which you would have to search for.
Okay, thank you. That's answers.
Mhm.
I hope all of your queries has been answered. And if there is any question, I request to write it in the chat box, or you can unmute yourself. Do we have any?
No, thank you. Okay.
Thank you. So also thank you to Sir, and thanks to all my dear friends from WebEx as well as YouTube for attending. And I hope you will connect with us in the future. Till then, stay safe, wear a mask, follow social distancing, sanitize yourself, and get vaccinated.
Thank you everybody for attending.
Thank you very much,
Thank
sir.
you, Ankit sir.
Thank you.
Thank